This is tutorial question N4. So this is a short pier or a column. It carries one load, and that load there is 450 kilonewtons. And it's eccentric to both the x and the y axis. And it says consider the stresses at A, B, C, and D, or work out the stresses at A, B, C, and D. It's a column where you can only make the assumption that the force is going to be is going a certain direction. Let's assume force is compressive. Doesn't say what it is. Normally, if it's a column or a pier, then it's going to be in compression. And we'll assume that compression is positive. So let's look at our direct stress first. The force over area. Put everything into newtons and millimeters again. Our area is 300 by 500. 3 newtons per millimeter squared. Now the problem with our moment, it's about 2 axis. So in terms of the bending stress, you've got your moment around xx. So our force times by this distance ex. So if we just say that there is ex. And then we've got my. So we've got this 25 millimeters, that's our EY. Now for our bending stress, we've got M over Z. You can get your Z value from tables or from our formula. Elastic modulus is Z, and plastic modulus is normally an S for a plastic. So when you look in the table, sometimes you've got Z and S. Problem is if you get some tables from America, they swap the letters around, where they have S for elastic modulus and Z for plastic. So try and make sure that you stick to UK. So our Z is BD squared over 6. What we've got to try and make sure is that we get the correct B's and D's. So if we were going to look around our Z across the XX axis, it would mean that this is our B, so that's 300. This distance down here is our D, because we're looking about this XX axis, so it's times by 500 squared over 6. And across the YY, our B would be 500 and our D is 300. So if we looked at our bending stress about the x-axis, we have our mx divided by zx. So that's our bending stress across the x-axis, vertically, across my over zy. That comes to 1.5 newtons per millimeter square. So now we've just got to put everything together. CD. The original question was, what is the stress at each of these corners? In terms of my formula, I have my direct stress Then I have plus or minus my bending stress across the x-axis, and I also have my bending stress across the y-axis. So we've worked out that our F over A, second sort of line down, was 3. So we're saying that it's compression. So what we have is 3 being applied at each A, B, C and D. In terms of across the XX axis, like we've got our MX over ZX is 1.8. So I'll put my 1.8 values in. Now, whether they're plus or minus. So if we're saying that we've got compression is positive, you can imagine that as it's pushing down, don't know how well you can see that, but if it's pushing down on this side, it will lean towards, in terms of the XX direction, so we're looking across this way, it will put C and D under compression. So our C and D are positive. Our A and B, it will create a tension along this side. That's why I've got minus. And then across our YY, our YY is 1.5. Going across, the load is going to be on the right hand side, which will create a compression along BC. So that'll be positive for B and C, and it'll create a tension along AD. So that's why we have minus at A and D. And then it's just a matter of working out these values. So they're all in newtons per millimetre squared. There's a slight bit of tension at A. But across B, C and D, it's all positive. So you have compression. Now, if there was a second load being applied to this, so if we had a load being applied there, and again, if that had its own distance in terms of its EY and this distance EX, what you would have to do is take the direct stress for this one here, add it, and then you would also be looking at the bending. So if it was on this side, it would be creating, as it's pushing towards this corner, it'll always be like a compression over here. But if a force is on this side, it will be creating a tension on this side. So you'll be adding the moments from this force, and you'll be taking away the moments at this side. So just imagine, it's just a matter of adding together all of the values. And there is an example online where we have a couple of forces